Elon Musk is a first principles thinker in modern times. Question was, if a rocket goes up, why can't it come down? Why do we just leave it hanging out there? A very basic question that led to Elon Musk's legacy. Because of COVID, so people are going to buy a lot of properties. So because the demand for properties is going to increase, the cost is going to increase. So they bought millions of dollars worth of property, and the plan backfired. They went bankrupt. When these fighter jets were going to Russia or other countries, pilots would die, jets would go off missing. So there was this scientist. He was like, hey, I got to protect my soldiers. I got to protect these planes. I'm going to take a very scientific approach.
If you are a tech geek with a keen interest in data science, AI, or machine learning, you are at the right link. On today's episode of Beyond Conversations, our guest is a data storyteller, Abhiraj Darshankar. Abhiraj completed his Bachelors in EnTC Engineering from Pune Institute of Computer Technology and went on to pursue an MS in Cognitive Science from the University of Texas at Austin. He currently works as an applied data scientist at Microsoft and is based in Austin. On today's episode, Abhiraj speaks in depth about how data science, AI, and ML systems work in the tech industry. He also speaks about his personal journey of building himself for success in the field. Elaborating on some of the finer details of the design of ChatGPT, he takes us into the future of ethical and resilient AI and the jobs it could potentially create. Thank you for joining us on this show, Abhiraj. Did you always know that you wanted to be a data scientist? How did this journey begin for you?
Well, that's a great question. It's gonna make me rethink my entire life, but I did not always know that I wanted to be a data scientist. The process was very gradual, personally driven by a lot of curiosity and desire to make sense of the world. Since I was pretty young, I was more inclined towards maths, physics. These were fascinating subjects to me because they helped me understand patterns in the world. All of this led me to pursue electronics and telecommunication engineering at PICT. And I owe PICT a great deal of exposure that I had, which led me to becoming a data scientist. For instance, PICT has a lot of events, right? Credence is one of them.
Yeah.
I remember co-founding Exodia with a couple of my friends, and the goal was people are going to write algorithms, but can we come up with a mechanism so that we can compare algorithms? So we created a platform where we'd design a game, people would come up with algorithms, publish it on our platform, and we'll make these algorithms compete against each other. So it started off like that, and Exodia roughly meant tic-tac-toe, Exodia. We started off with tic-tac-toe, and at one point, we stumbled upon a piece of code which closely resembled reinforcement learning. So every time that bot played a game, it was improving. That is when Exodia shifted from just being a platform for algorithms to fight to becoming somewhat of an AI hosting platform. So it was fun. I got introduced to reinforcement learning, and AI had the space of smarter algorithms in general. And when I talk about algorithms, right, as a field in mathematics, I think there was a Persian mathematician who came up with a procedure called Al-Khwarizm. And the goal was to be able to automatically solve linear equations, right? You start off simple and you start building upon things. Something else I remember is when I gave my CET, I had a hard time finding colleges or finding information, a comprehensive list of information about colleges.
Right. Yes.
So, yeah, you probably relate to that.
Of course. There's like 100 websites that you need to juggle through, and then you speak to a lot of people, and that's when you understand, okay, maybe this is the right choice.
Yeah. And it's unfortunate, right? A lot of information is available online, but nothing is summarized. I actually worked with a couple of friends and my dad. We built an Android application called CET Guide. And our goal was to have a centralized place to host all information about colleges. And my dad, he is a bit of a techie as well. But my dad was like, you know what? I have a team at work, I can ask them to collect information about colleges.
Right.
And 5 people, we've got about 800, 900 colleges all over India, maybe hundreds of colleges. We can give them a week and they'll collect all the information and get back to us. And I was like, maybe there's a smarter way of doing it. And I remember building a web crawler. It took me 2 days to build a web crawler. Then I let it run. It went on from one college website to another college website, gathered all the information in a database. Then we applied some summarization over all of that info, and we had this app. You might still be able to find that app on Play Store, but
What's the name?
CET guide. I'll see if I can find it. It's been a long time. I'll share a link with you once we're done with the podcast.
Sure, we'll put it in the description.
Yeah, absolutely. We can put it in the description. That was my introduction to world of insights and information processing. That led me to pursue my master's in cognitive sciences and intelligence systems here in the States. And I started off with a keen interest in information processing. So master's in the States comes with an option of doing research. I was passionate about research. Me and a couple of friends, we'd started working on a neural network. We called it code to vec. So taking codes, converting it into vectors so that we can do arithmetics with code. Few years later, GitHub Copilot is exactly what we were trying to do, right? It takes a piece of code, it's able to vectorize it, it's able to apply arithmetics on it, and it's able to recommend stuff. It's able to help you one-on-one. And underneath, it's all arithmetics, plain arithmetics, but
Right.
that's the crux of it. So that's where my master's started. And after my master's, in my first job is where I started applying all the theory to the real world. I played around with things like self-supervised framework, building language model for... My first job actually was in automobile industry.
Oh,
I was a data scientist for automobile industry. So I built a language model for the mechanical domain that was put to good use, where we were seeing if we could replace basic mechanical internship level problems with this language. But of course, it was just a language model. It wasn't a large language model.
right.
What ChatGPT is able to do right now, the tools and technique, the theory behind it has existed since a long time. A lot of people have tried to build what we now know as ChatGPT, but I think the timing was off. Big data did not exist, or the computation power did not exist, or a good way of engineering the data did not exist to a point in engineering, or to the point in our world where humanity came to a point where everything was good enough. And that gave rise to ChatGPT, right? So that's how my journey began. I did not know I wanted to be a data scientist. It all started with curiosity, but I'm glad to be where I am right now.
That's true. It seems you really did have quite a visionary approach to building applications. And that's where your interest came in. And that's why you were able to build such amazing things, especially Exodia is something, I don't think it's actually an event at Credence now, but a lot of the alumni who I've contacted for the podcast still mention, okay, do you still do Exodia? And so yeah, finally I got someone on the podcast who had actually built it.
Yeah, Exodia, even back then, it got a lot of attention. We had people from Russia submitting codes to us. So I'm fascinated as you are. It ended up being a big success, but that wasn't the intent. We just were a couple of kids wanting to play around.
I think one of the dilemmas that people in tech and students deal with on a very large scale is whether you should be a specialist or a generalist, whether you should focus on just one domain or whether you should, be a jack of all trades. What is your take on this dilemma?
Well, it's an age-old debate. I don't think humanity is ever going to come close to solving it. We can think of it this way. I'm sure everyone has come across the quote, jack of all trades, master of none, suggesting generalization is better. There's another quote by Robert Heinlein that goes something like, it's a long quote, but it goes something like, a human being should be able to change a diaper, plan an invasion, butcher on corner ship, design a building, write a sonnet, give orders, take orders, cooperate, act alone, solve equations, analyze few things, pitch maneuver, program a computer, do accounting, cook a tasty meal, fight efficiently, die gallantly. Basically, specialization is for insects. So you've got two quotes that say specialization is bad and that generalization is good. Maybe it's easier to conclude that generalization is better, but I want to go a bit more into details of what the domain of data science actually looks like. In the tech industry, I don't think we are insect. I don't think we are jacks either, but we are also not polymaths like human and linguists. I think we're going to be somewhere in between. We need to have a certain breadth of knowledge, a good foundation in many areas. It will enable us to have multiple tools to do multiple things. At the same time, there is also a need for depth in at least one or two areas. Thinking about specialization and generalization, I know I'm being too vague where I'm saying you should generalize and specialize at the same time. What I'd say is start off with generalization. Get to know a little bit of everything, because that is not only going to help you understand what you like, what you dislike, it's going to help you develop good general knowledge. It is going to give you a good sense of the world. And once you have a good sense of the world, start to specialize. Specialize at least in one or two areas. And you might ask, how would someone decide which area to specialize in? There is no standard answer for it. Where to specialize in is a very good question, which depends on a lot of factors, such as an individual's interest, the demand in the job market, the future prospects of the field. But ultimately, you have to be passionate about it as well. You have to do something that's going to drive you to keep learning and improving. With all of that, what I want to say is there is a Japanese concept of ikigai. Do what you love, do what the world needs, do what you can be paid for, and do something that's your strength. If you do something that you don't love, it can be a profession or a vocation. I don't think it's going to be sustainable. At the same time, you have to develop strengths to be competent. But knowing where to build your strength, you have to generalize first. Start off with generalization, start off with learning a little bit of coding, start off with reading some use cases, start off with understanding how people use data science, where are they using it, try to understand the latest and the greatest trends. Try. I'm not saying you're going to understand. You're not going to understand overnight how ChatGPT is working, but you can get a high-level understanding, generalize, and as you understand a little bit of everything, it'll automatically come down to your curiosity being triggered. As your curiosity get triggered in one of those aspects, you'll automatically start specializing. Don't resist it. Be with the flow, listen to yourself, and enjoy the process.
Right. I think that's a very holistic answer. Instead of, being too caught up or tangled up in, am I doing the right thing? You could just listen to your own inner voice with a little bit of feedback from all of the 4 dimensions that you mentioned. What is it that you love? What is useful for the world? What is something that will sustain you and that you can sustain on?
Absolutely. That's a great summary.
Coming to the next question, as students, we really look up to the products of AI and data science like ChatGPT, which is a really fascinating product wherein you can, it's a chatbot and you can give it a text prompt. It will basically go all over the web and summarize information for you as if it's a person who's, talking right back at you. So as students, that's something we will get fascinated with, and we will think of ourselves as the engineers who will, go on to build something like that. But starting out, you really don't know the process of how do you get there? How do you climb up those steps from 0 to 100? So do you have a framework to learn data science?
I completely agree with you. Data science is as complex as it gets. Let's simplify things a little bit, right?
Sure.
If I have all bike parts lying on the ground right now, how do you start building the bike? You're probably going to pick up a frame first, right?
Yeah.
Start mounting wheels.
Yeah.
What would you like to do with?
So I'd basically, I'd try to make the chassis first, then I'll, put in the wheels. I'll see where things should connect. I'll think of what are the use cases or functions that, I want the bike to function in, and then I'll put in parts according to that.
And that's a great approach. You not only are you thinking about just putting the bike together, but you're thinking out the purpose of the bike. And you're right when you say the bike could be built for a kid, the bike could be built for racing, built to be driven in the mountains. So all of those factors come in. But I don't think we are ever going to get to knowing about metallurgy and designing the chassis, melting the metal, right? We're going to pick up those pieces, put them together. And that is what data science is. It's an interdisciplinary field.
Right.
It comprises of machine learning, coding, visualization, and domain knowledge. And domain knowledge is important. What you talked about, knowing what the bike is going to be used for, is domain knowledge. So there is technical skills and then there's domain knowledge. Technical skills will teach you how to do things. What to do comes from domain knowledge. And piggybacking off of the previous question, whether to generalize in data science or you can specialize in machine learning, right? Specializing in machine learning is like learning to build tires. If you are the person who wants to build tires, you'd be expected to know what type of materials can a tire be made of, what kind of friction coefficient is needed.
Yeah.
You would be expected to know the difference between using a rubber, between using a plastic, between the lifetime characteristics of different materials and so on and so forth. So specializing in ML is like specializing in how to build tires. It's another rabbit hole. It's complex by itself. But if you want to build a bike, all you need to know is the type of tire, the dimensions of tire, and then you start putting things together. If you want to specialize, you can specialize as well. Data science in itself is a very generalized field. You can specialize in different things. And going back to your question, right? How do we think about learning data science? I think we talked a little bit about what data science is. But before we talk about how to learn data science, I want to talk a little bit about how to think about data science.
Right.
Or even the subfields. And one framework that helps data science significantly is scientific methods. Scientific methods, I think, has been one of those things which is simple but has such a vast impact on humanity. By far, I could say that it's one of those very simple things that has given rise to the entire modern field of science. It's probably one of the best things humanity has done. What exactly happens in scientific methods is very straightforward. You observe things. As you observe things, you try to process and break things down into simpler chunks. You build hypotheses over your observations. Your observation could be apple is falling from the tree.
Right.
Your hypothesis could be something is pulling the apple down, or apple is attracted to the earth. If we were to think about ChatGPT, my observation is I ask a question and ChatGPT responds. My hypothesis could be ChatGPT knows what I'm asking. It understands what I'm asking. It is able to think about my request and it's able to think about my request and come up with a response. That could be a hypothesis. Once you have the hypothesis, you test things around. You break things into simpler chunks and you test things around. So in case of the apple, I could replace apple with a paper, with a feather, with a metal ball, with a glass, with a person. I can see how gravity works. Or the goal is eventually to reach gravity.
Right.
But I don't know gravity exists. In case of ChatGPT, you could ask ChatGPT different types of questions. You could ask it whether it's able to think or not, right? Eventually, with gravity, our goal is to discover gravity. With ChatGPT, our goal is to uncover that ChatGPT doesn't really understand what I'm saying, but it's able to retrieve the right kind of information based on my request. So you start off with an observation, break things down, build hypotheses, you test and experiment, play around with the thing, and then you reach conclusions. Your hypotheses can be true or false. If the hypothesis is false, you come up with new hypotheses. Because apple falls down, fine. Feather doesn't seem to be falling down the same way. Something is pulling everything into the earth is not going to fit well. So I've come up with a new hypothesis that maybe something is not pulling things randomly towards the earth. It's a mesh of factors acting together. What are those factors? You again observe. You build hypotheses.
And
and so
that's
on. So
when you would, observe further about what are the factors that this apple or feather, why do they differ? What are the factors that it depends on?
exactly. And the reason why I wanted to talk about scientific methods is because that is what data science is. We call it data and we call it science. So data
Right.
science without scientific methods is incomplete. So before learning data science, having a holistic understanding of scientific methods is going to be paramount. The second thought framework that is going to help anyone interested in data science a lot is post principles thinking. In post principles thinking, it's more of an addendum to scientific methods. It is a way of thinking where you ask questions like, why does it have to be like this? What is the very basic truth or fact underneath a certain assumption, a certain hypothesis, and so on and so forth. So you bring things down to the most fundamental truths, the first principles. Um, Talking about first principles, Elon Musk is a first principles thinker in modern times. And we saw how he was able to revolutionize the space industry.
Right.
First principles thinking, right? The question was very simple. The question was, if a rocket goes up, why can't it come down? Why do we just leave it hanging out there? A very basic question that led to Elon Musk's legacy. So first principles thinking in addendum to scientific methods, that's a very powerful thought framework. And anyone interested in data science, highly recommend that they read a bit about it, start applying it on your day-to-day life, because in real world, if you become a data scientist, that's exactly what you're going to do. You're going to observe the data, you're going to build hypotheses, you're going to break the hypotheses down to first principles, you're going to analyze things, you're going to build conclusionary reports, and so on and so forth. So that's a bit about data science. And if you want to learn data science, there are plenty of materials. There's plenty of material available out there.
Yeah.
You have blogs like Towards Data Science, Katie Nuggets, Machine Learning Mastery. There are some influential people, Andrej Karpathy, Andrew Trask, and hopefully we can have all these links in the description.
Yeah, of course.
Yeah, these are some really good blogs to start off with. YouTube, I feel like, is a popular way of learning lately. So there are some channels like 3 Blue, 1 Brown, talks about maths and statistics, StatQuest. You can watch conferences on YouTube. Then there are podcasts as well. Doing data science on podcast can be tricky because it's all audio. But one podcast that I really like is Machine Learning 101 by Dr. Richard Golden. Amazing podcast. He covers both the applications. He talks about the intuition behind the math while skipping the math. But you'll also learn to think about the math a little bit. And with the material in place, I think next question is, what should you read? There's plethora of information out there. I think at what point do you say you know enough about data science? And to that, I'd say a general framework, a general target should be being able to read data science research papers. There's a rush. It'll probably take 2-3 years, 4 years maybe. For me, it took roughly 2-3 years till a point where I could read a data science research paper without being able to open Wikipedia, without starting reading the paper and not understanding what's there, going off on a tangent trying to learn this new thing, then learning this another thing, and so on and so forth. It took me roughly 2-3 years to be able to reach that point. But keep reading, keep learning. There's plenty of material out there. Think about scientific methods, think about first principles thinking, and think about bike analogy. Know that it's not complex. It's just something that we've got to build one thing on top of the other. And that's how you'd learn deals.
Right. I think you had some very unique analogies when you were speaking about both scientific methods and first principle thinking. And they will, of course, be very helpful. And what you said about reading research papers. So for most people who are trying to break into a particular industry, they always think about, especially in tech, it's like, okay, I built an application that was related to this. And there's a lot of theory that you really don't know. You're just building something. But that's something I totally agree with, that unless you know what's going on behind and why you're writing, let's say, a certain piece of code, you wouldn't actually exactly be able to, optimize your model.
Absolutely. And in the end, that's the name of the game, right? Being able to use it.
Right. So we spoke a bit about, scientific methods. When we think about pure sciences, or what you think were the crucial steps to building up modern science as we know it today, the pictures that come to mind are, there's a laboratory, there are some experiments being carried out, some people in lab coats, microscopes, a lot of research that is based on observations. You're changing test cases of whatever you're trying to test. Let's say, there are people testing the psychology of animals, people trying to test chemicals in order to build medicines. Whereas when we think about tech, it's the picture that actually comes to mind is that, there's someone behind a computer, there's a team who are working on different computers on a common goal, which is to meet a particular business need. And when you're speaking about data science, it's kind of an amalgamation of both tech and science. So can you tell us about the process of data science? How does this thing work?
Yeah, I love the analogy. And you're right, data science is a mix of both. It's going to be a mix of you wearing a lab coat and you having a screwdriver in your pocket. It's
Right.
going to be a lab exercise where you're experimenting, but you're also engineering and designing things. Thinking about analogies, I think the beauty with data science is it's more like being a detective as well. What I mean by that is data science is like you're presented with a crime scene, if you will, in form of the raw data. Your job is to find patterns, relationships, insights hidden in the data. With this analogy in mind, let's see what we can uncover about the world of data science, right? So you've got a crime scene, you are a detective. Big data is a team that comes and collects all the evidences, right? You
Right.
use stats, machine learning to interrogate the data. Or let's say if you have boxes and boxes of evidences or have large amounts of data, you're going to rely on something called as data mining,
Right.
right? Data fabric is like a map of the city where you, the detective, operates. It's the architecture that allows the data to flow seamlessly from one place to another place, enabling you and other detectives to find the relevant data or relevant evidences quickly and effectively. So we talked about big data, we talked about data mining, we talked about stats and ML, we talked about data fabric. With this, I, as a detective, probably can work standalone.
Right.
But
So
I,
you have all the resources, and using all of these, you will be able to find out who the culprit is.
that's the hope. Uh, but here's the thing. One detective does not run CID, does not run an entire investigative department. There are multiple detectives, there are multiple the managers, there are people who do accounting and finances, they're going to be cops, they're going to be people who specialize in um, certain aspects. Maybe someone is good at uh, crime or cybercrime, right? And so on and so forth. Point being, doing good detective work is not just me being good or data scientist being good. It's about a lot of people coming together and making things work.
Right.
That's where data democratization comes into the picture. It's somewhat of a tongue twister, data democratization. But yeah, the idea with that is everyone in the organization, not just the data scientists or IT department, should have access to data and the ability to make use of it so that they can have more informed decisions. It's like deputizing every citizen in a detective city, empowering them to solve their own mystery cases in an extreme world.
Yeah, that sounds like a great analogy. I think you kind of, put down the entire process in a step-by-step way, what comes after the next. But let's say if you don't give an analogy, if you're to put it in, let's say, building an application perspective, how would you describe it?
Well, you would start off with big data or data engineering, which helps you just get access to data. Data fabric builds upon big data or data mining tools. And what data fabric does is it's a unified framework for a unit. So Microsoft recently released their own a product called Microsoft Fabric. It's an analytics platform, but in reality, what the core of Fabric is having a unified framework where all the data, where I have information about the crimes being solved, where I have information about the different detectives, where I have information about different citizens, people, where I have information about who does what and everything in one singular place. So
Right.
everyone has access to all the information. That is data fabric. It's a step up from big data. Data democratization is being able to have everyone collaborate on this data fabric. There's one more term that I'd like to coin here, data governance. Data governance is where we make sure that the detective, and I'm going to analogy and come back to data governance and where it lies in the real world. Data governance is, you can think of it as rules and regulations that a detective must follow. It includes things like data security, privacy, access, considerations, ethical consideration. It ensures that detective doesn't overstep their boundaries or misuse the data. In real world, what data governance looks like is if I have a database of crime and I have an analyst, maybe the analyst, his job is to give monthly reports to the citizens. These many crimes happened. These were the types of crimes. These were the places where the crimes happened, and so on and so forth. He does not need to know who the crime happened with, who were the victims. That information can be misused. Data governance can help anonymize data. It's a layer on top of, not on top of, but it's more of an integrated layer with the fabric where different people accessing this fabric will see different view of the same data.
Right.
So to put things together, data, big data, data fabric, data governance, and data democratization, these are data access frameworks. These are upcoming frameworks. A lot of companies are trying to establish them because it's the right thing to do. Once we have right access to the right kind of data, that is where we come up with stats, ML, data science, and every set of analysis is going to look different. But there are upcoming things like auto ML, where you can take certain set of data and do automated experimentations based on a certain objective function. So first part, data access, second part, experimentation. In today's world, we have a lot of frameworks coming up to support data access and support wise, reliable data access. There are frameworks coming up in the data science or the analytical side of things, but it's still upcoming.
Right. I think that gave a lot of aspects for, enthusiasts to consider that these are the different things that you'd look at when you're going to implement a process. And I think the analogy was really, really fantastic in terms of a layman can understand it. So,
Right.
yeah, that was a fantastic analogy. And,
There's
Yeah, go on.
the thing though. Talking about data analysis, right? Data analysis, we don't have physical frameworks in data analysis, but there are conceptual frameworks in data analysis and the way data analysis works. Whenever we get access to data, it's a 4-step process. We start off with descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Descriptive analytics is where we figure out what happened, looking at the historic view of data. Diagnostic analytics is where we figure out why did it happen. Diagnostic analytics involves things like root cause analysis, A/B testing, and so on and so forth. Predictive analytics is built upon diagnostic and descriptive analytics, where we use
What's going to happen next?
What's going to happen next, right? And prescriptive analytics is where, based on what has happened, why it happened, what will happen, what we are trying to do is we are trying to prescribe how can we make it happen. Here is where the true high risk, high value element of data science lies. This is where complex systems, recommendation algorithms, simulation algorithms, what if simulations, etc. come into the picture, where we try to prescribe a set of actions to reach a desired goal. But it's a 4-step conceptual framework. Do we see it physically embedded in any system? Not really, but it's something we try to abide by.
Right. I think that is again a very interesting, conceptual breakdown where you're speaking about what are the 4 steps of how you'd go about building a data science model. And that's taking us to the next question. So you told us the story about, let's say, a crime scene, and the detective will basically uncover the entire story to reach where the culprit is. And that takes us to the point of data storytelling. Stories is the first form of education that we accept as children. They're very important to how we understand the world. So let's say today we are living in an era of information, and let's say, for example, Netflix is one of the applications that collects a huge amount of data. So Netflix will collect what are the shows you're watching, what amount of time do you watch them, how often are you watching them, where are you watching them from, and it will sort of, using these data points, it will convert this into information and into a story about you. What are your watching habits based on the data points that it has collected? And you describe yourself as a data storyteller. So what does that mean for you? What does it mean in the industry?
Right, that's a great question. Data storytelling is important, and it essentially comes down to communicating the findings from the data in a way that's engaging, accessible to everyone, and not so tech-savvy people or not illiterate people can also understand it. Basically, it comes down to making data relatable. And just like how you said with Netflix, where it weaves a story about your watching habits, as data scientists, we are doing the same with whatever data we get our hands on. The data points are like different characters and events in a story. And it's our job to find the narrative that links together and puts this story in a coherent and meaningful way. And why do we want to do that? In the end, it's not about the data. It's about the people, the stories we tell, the decisions we make, and data is just something that's going to facilitate all of it. Netflix does a lot of heavy lifting to help us figure out what to watch. The goal is always going to be people.
Yeah, that puts into perspective, how the entire creator ecosystem also works when you can directly, relate this to YouTube and all of those things where they're going to observe the patterns of you, and then they're going to build, okay, this person is, let's say, interested in these things. This is his approximate age, and this is what we're going to suggest him.
Right. And it's not as simple as it looks, actually. Data and storytelling in general is a very challenging space. It's not something, at least for me, it's not something that comes naturally. And talking about myself, what I have on my LinkedIn profile is more of an aspiration. I think becoming a data storyteller is a journey. There's never going to be a point where you're like, hey, I'm a data storyteller now. It's always going to be a
work in progress.
And the work in progress, because when we talk about data storytelling, it's about the people. No two people are the same. No two audiences are going to be the same. And irrespective of that, data storytelling in itself has a lot of challenges. Some of the challenges, for instance, are oversimplification, our cognitive biases, ensuring that the story doesn't overshadow the data, and so on and so forth. But that's on a high level. To put these challenges in a simple, more consumable way, right? Oversimplification is where I want to call out Zillow here, for instance. Something that happened with Zillow is Zillow ended up buying, it's a real estate tech company here in the States. I'm not sure if it has a presence in India, but they ended up buying a lot of land, a lot of properties right around when COVID was starting.
Right.
And they estimated that because of COVID, people are gonna not work from office anymore, they're gonna work from home. So people are gonna buy a lot of properties. As people buy properties, if we have a lot of properties, so because the demand for properties is gonna increase, the cost is gonna increase. So they bought millions of dollars worth of property, and the plan backfired. They went bankrupt or close to being bankrupt. Why? They, in the back end, the culprit was the data science team. Data science team oversimplified things. The story that they told was as people buy more houses, demand is going to increase and prices are going to increase. But the story is not really as simple as that. There are a lot of underlying factors. You not only have to look at the demand, but you also have to figure out what's happening with the commercial spaces. If people are not working from office, commercial properties are going to be weakened. Demand there is decreasing.
Right.
So all in all, you have to weigh everything. Your analysis has to be holistic. Your story has to be holistic. You don't have to oversimplify things, but the goal is to have a holistic point of view.
Right. I think that puts a lot of things into perspective. It's supposed to tell a story, but not one that's, that's devoid of the outliers. Or you'd have to think about what are the multiple aspects of a particular story rather than, this follow a particular storyline. This is the beginning, this is the middle, this is the end.
Right. And that's where cognitive biases come into the picture as well. Some very popular cognitive biases that we as data scientists, so me and my team, we try to hold each other accountable. These are cognitive biases humans are prone to. We have to unlearn or learn new ways to unlearn things like selection biases, survivorship biases, cherry picking. And I want to throw out an example. It's a very popular example that people quote for survivorship biases. India right now is seeing a lot of startups booming.
Yeah.
And I was having a conversation with a couple of friends who were thinking of starting a startup. And this space right now is the most prone to survivorship bias, where you look at startups, you look at their strategies, you look at successful startups, you look at the strategies that made that startup successful. And it's very easy to think, if I follow this strategy, I'm going to be successful. But that ignores the bucket of ventures which started, followed the same strategies and failed. Survivorship bias is where you only consider data points that about things that survived, and you fail to account for data points. You fail to account for things that didn't survive. Another very popular example is in World War. There was a project being led by airlines, by fighter airlines or fighter jets. When these fighter jets were going to Russia or other countries, a lot of jets were not able to return to their base station. Pilots would die, jets would go off missing, jets would die, and so on and so forth. So there was this scientist. He was like, hey, I got to protect my soldiers. I got to protect these planes. I'm going to take a very scientific approach. He looked at the planes that were coming back. He found out that a lot of planes that were coming back were being shot around the wings.
Right.
And the back tail of the jet. He came up with a fantastic plan to cover the wings and the tail of a jet with a titanium plate from below. And they released this pilot program. They spent about a month or two assessing how it's helping, but they found out that the survival rate or failure rate of jets was remaining the same. Jets were dying with the same frequency, same amount of pilots were dying out there in the world, and no one had a clue why. It kind of hints to survivorship bias, but do you want to try and decipher this?
Sure.
Why do you think the program failed?
Because that wasn't the thing that they should. I mean, of course, they thought of covering up the wings and the tails, but maybe there was some other factor that was into play in making the airplanes fall.
Yeah, and the other factor was they were looking at planes which were coming back to the base. They were not looking at planes which were dying off. Planes which were dying off were generally being shot on an engine or fuel tank. And that makes sense, right? If you get shot in the engine, if you get shot in the fuel tank, your plane is probably going to explode. If it gets shot in the wing, it's probably going to be able to come back. They build this entire program, amazing plan to protect the soldiers, but it failed because we failed to account for a simple cognitive bias.
Right. And then that I think will, somehow resonate with how you analyze data. What are the things you are looking at and what are the things you're supposed to look at? So I think that would be a very crucial part of data science is to look at the right things.
It is to learn to look at the right things. And that's about data science, right? As data scientists, we have to learn to look at the right things. Domain knowledge is very critical for that. But beyond that, that is not where the challenges stop. When it comes to data storytelling, it needs a lot of empathy. Like I said, understanding of the domain, understanding what people care about, understanding what people know,
Right.
being able to educate people where education is needed. Sometimes I end up feeling like a psychologist where I'm trying to analyze people and the audience so much, but it's part of the job because in the end, your role is not to do data analysis or find insights. It's the end goal is to be able to create some impact through it.
Right. Speaking about impact, you're working at Microsoft. Microsoft has had a huge impact on the world. It's cited to be the first real software company, and it's credited with putting a PC on every desk in every household. So, how did Microsoft happen for you? How did you prepare yourself for Microsoft?
Well, getting into Microsoft was no walk in the park. It was a combination of preparation, opportunity, and a bit of luck. Luck is not something that's in our hand, but preparation and opportunity, grabbing opportunity definitely is. So I'm going to talk about a couple of things here. And it's not just true for Microsoft, it's going to be true in general for any data science role. Because the fact is, me being able to work at Microsoft isn't a function of me being able to work at Microsoft. It's a function of how good I am as a data scientist, what I'm offering, how quickly the domain knowledge can be grasped, how handy am I with technical skills, and so on and so forth. So there are multiple facets to becoming a successful data scientist in general. Experience is also important. And I want to call out a couple of things. I think my experience, my journey to becoming a data scientist at Microsoft or becoming a data scientist in general started back in PICT itself. One of my bachelor's project was PICT. It was a computer science project, a computer vision and computer science project where we're trying to build a hand gesture recognition tool using Python. It's very popular. You're going to be able to find a lot of how-tos, getting started videos, but we just wanted to try it. I played around with NLP really early on. I played around with algorithms early on. And all of this to say that experience, getting your hands dirty, gives you a lot of insight into how things function. Theory is one thing, experience is another. Domain knowledge is the third thing. The tech skills part comes from experience, projects, and theory. There's something very interesting about domain knowledge. Learning domain knowledge is not like rocket science. Learning domain knowledge once in any vertical gives you the ability to scale learning a domain knowledge to any other field. And what I mean by that is, let's say you are planning on doing neuroscience research. And you're trying to figure out and cure brain aging. First thing you're expected to do is know a bit about brain, know a little bit about neuroscience, learn about brain anatomy, and so on and so forth. That's the domain knowledge. Once you know all of those things, then you need to have some skills. Maybe you're gonna come up with different chemicals, do some A/B testing, do some interventions to figure out how it's impacting, probably not human brains first, probably rat brains. That is when the technical skills part come into the picture. So you start off with domain knowledge. Once you have a good grasp on the domain, You use your technical skills to be able to play around with the domain, experiment with the domain. Once that's done, you can if you switch your job, if you go to a new field, let's say anthropology, you're probably going to have to do the same journey. You're going to have to understand the domain and apply some tools. But because you've understood one domain well, you've understood what you need to understand in one domain, you're going to be faster in understanding the second domain because you know to ask all the right questions. You know you have the abilities to now judge your domain knowledge and so on and so forth. So how does this relate to Microsoft and my journey in becoming a data scientist here? First, things started with projects, playing around with things, building some technical knowledge. But building technical knowledge as a student was just part of the picture. Getting into the industry and gaining some experience, doing internships was the second piece of the puzzle or the second Lego block. Once you start placing these Lego blocks of technical skills, understanding the domain, being able to play with the domain a little bit, understanding the domain even further in more depth, and going back to specialization versus generalization conversation, right? You build technical skills horizontally, but you start specializing in something one by one.
Right.
You keep on doing it consistently, you'll find yourself doing a good job at what you're doing. And it's not just true with data science. This framework will scale well to any other job, whether you want to be a software engineer, whether you want to be a neuroscientist, whether you want to be a psychologist. Tools, ability to play around with things, domain knowledge, play with it, gain more domain knowledge, go deeper, learn more tools to play around with it, and so on and so forth. Layer this, build Legos on top of each other, and someday you'll find that you're working at a place where you can create real impact.
Right. Thank you for tuning in to this episode. If you found it valuable, I kindly ask you to share it with others who may benefit from it. I highly recommend subscribing to our channel and exploring our other podcasts, all designed to support the student community. Additionally, make sure to visit the description for important links that will connect you with us. We look forward to seeing you again soon. Wishing you a wonderful day ahead.